Alright, this is how to break a vector into its component pieces. A vector is an arrow that shows both magnitude and direction. When that direction is not along one of the axes, it is usually beneficial for us to know how far on one axis and how far on the other axis it's moving, or what kind of a distance it's representing. So here I have a vector that's 9.5 units. That's a 9.5. If you can't read my handwriting there's a decimal. And what we're going to do, and it's sitting at an angle of 27 degrees. 27 degrees is the angle. This guy is made up of two different components. One component lies along the x-axis in the negative direction, so it's pointed this way. And then the other component lies along this axis on the y in the positive direction. So we could say that that vector has both a negative and a positive component to it. Notice that when we add these two pieces together, it gives us the resultant of a triangle. So this, by its very nature, is a right triangle. That makes this guy the hypotenuse. Since I know my 27-degree angle here, this becomes my adjacent side, and this becomes my opposite side. And so to break into components, I can start like with the adjacent here. I know that the cosine of theta is equal to the adjacent over the hypotenuse. Or I could rewrite that in terms of the adjacent side, ADJ is equal to the hypotenuse times the cosine of theta. Plugging in, the hypotenuse is 9.5 units. Cosine of our angle, which is 27 degrees, is equal to ADJ. Remember that in this class you want to make sure you are in the degree mode with your calculator. And if you do that and punch that into your calculator, the calculator is going to spit out an 8.4645 yada yada yada, which, because I'm limited to 2 sig figs here, I will simply say that my adjacent side, or my adjacent component, is equal to 8.5 units. To get the opposite side, I'm going to exploit this sine of theta relationship, which is the opposite over the hypotenuse, or the opposite side is going to be equal to the hypotenuse times the sine of theta. If I plug in there, OPP is equal to the 9.5 times the sine of 27. If I throw that into my calculator, then the calculator will spit out for me 4.3129, which, again, because of the 2 sig fig rules, I could just say that the opposite is equal to 4.3 units. And so these are the two components that make up this 9.5 unit vector at 27 degrees.